Welcome back. This is going to be box plots day 2, or box and whisker plots day 2. So continue where we left off. We just talked about the basics of them, and we're going to do more details today. All right. So real quick overview. This is what a box and whisker plot looks like. It's a method for graphically depicting groups of numerical data through their quartiles. So this is like a median type of deal. Uh, a box and whisker plots should look like this, and we're going to create one here in just a sec. In order to create this, you need those 5 numbers, and it's usually called our 5-number summary. And this can all be found by putting your numbers in order from least to greatest. You can find the median, you can find the maximum and the minimum, and then the quartiles are just what's in the middle of the left side of the data and the right side of the data. On either side of the median, what's the median of those? Those are the upper and lower quartiles. There's also a way to identify outliers. So we have these outliers over here. If there's any outliers, they would be 1.5 times the IQR, which we've talked about IQR. That's quartile 3 minus quartile 1. That's taking that quartile 3 and adding that. If it's higher than that, it's an outlier. Same thing on the left side. If it's quartile 1 minus that, and it's outside of that, it is an outlier. So we did the 5-number summary. We talked about how you can take numbers like this yesterday and put them in order from least to greatest, and then find your quartiles. One, two, three, four, five, six, seven, eight, nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. So your quartiles would be right here. Our middle value is our quartile 2. That is also called our median. Now on either side of that, then we look for our quartile 1 and 3. So in the middle here, which is 4, that's our quartile 1. In the middle here, which is 7.5, that's our quartile 3. Our minimum is 3, and our maximum is 5. Those are your 5-number summary. That's what we would use on a box plot. And if we have that, it's kind of already in the look of a box plot. So now we want to actually create a box plot. So how do we do it? We're going to set up a number line with equal intervals, label the axis, and put a title on it. We're going to set up the number line with numbers that actually make sense for our data. Okay? Do not have to have everything. We're going to then generate our 5-number summary. We need those 5 things because that is what makes up a box plot. We're going to also have to do this math. So we're going to take our quartile 1 and quartile 3. On the right side, we're going to add 1.5 times the IQR to the quartile 3 just to see our highest boundary that we can go. If it's outside of that boundary, it's an outlier. Likewise, on the lower end, take your quartile 1, subtract 1.5 IQR. That's our boundary. If it's outside of that, it's considered an outlier. Okay? You create your box plot and plot your outliers if they exist. Draw your whiskers, which would be your maximum, minimum, and label anything that needs to be labeled. So let's go ahead and do that. We did talk about the other day about how you can take this data, you can put it into your calculator and list 1 or whatever list, and then you can do 1 variable stats to find the 5-number summary. So what we're going to do here is we're going to take our, we're going to do grams of fat. And we're going to find the 5-number summary, and we're going to use that to make a box plot. So I want to make my number line right away just so I know kind of a range. It goes from 8 all the way up, it looks like, to 17. So I can number that by ones, no problem. So if I have my number line, oh, there we go. I have it down there already. Got it, 7 through 18. That'll be enough. I'm going to label it. I'll put a title and label, but the bottom it's going to be, what did we say this is? Grams of fat in candy bars. So grams of fat. Ooh. And my title will be box plot. I like to abbreviate that. It's technically a box and whisker plot, but a lot of times you'll hear it as a box plot of candy bar fat and grams. All right? So let's find our 5-number summary. That's the first thing we want to do. Actually, the first thing we did was our number line. We're going to find our 5-number summary next. So we need our minimum, our quartile 1, our median, which is our quartile 2, our quartile 3, and our max. Now, the nice thing that I'm going to utilize here, instead of writing out all 27 values and finding those, is my calculator. So on the calculator, if you go to Stat, and you go to Edit, Enter, you can put them all into List 1. I did List 1. If you want to choose a different list, go for it. But I have all my data values put in there. Now, I'm going to go to Stat, and over 1 to Calc, and hit Enter for one variable stats. I'm using list 1, leave frequency list empty, and calculate. So we have things like the mean and the standard deviation, but we're looking at 5-number summary, which is all right here. Minimum is 8, maximum is 17, median is 13, quartile 1 is 11, quartile 3 is 14. These are all nice numbers to work with. So we're going to work with those right now. So 8, 11, 13, 14, 17. So there's my 5-number summary listed there. I'm going to need to now find if there's any outliers. So what I want to do is figure out the IQR, the interquartile range. So that is going to be Q3 minus Q1, so that's 14 minus 11, which is 3. Not a crazy interquartile range, but I'm going to do some work off to the side here to figure out if there's any outliers. So my lower bound is going to be 11 minus 1.5 times that IQR of 3, which will get me 6.5. 1.5 times 3 is 4.5, and if I take that away from 11, I get 6.5. Is there anything lower than 6.5? There is not. So I'm going to say none. Now I'm going to do the second one. I'm going to do upper quartile. So 14 plus 1.5 times 3. That gets us an upper bound of 18.5. Is there anything higher than that? No, there is not. Which means there are no outliers. So we don't have to worry about that in this case. So I'm going to now draw my box plots, my box and whisker plot. After I've already done all of my work to get there, I just need to use my number line, keep everything consistent, and I'm going to start with my median at 13, like that little box right there. The other parts of that are 11, so here's the other part of that box, and then 14. Here is my box. Now let's make the whiskers. The maximum is 17, and the minimum is 8. If it is a good box and whisker plot, it should be clear what those numbers are, but you can always add those on here, 8, 11, especially if you're dealing with decimals ever. Put those on there, and then it's clear. If you want to add up here as well, quartile 1, median, quartile 2, sorry, 3, you can do those things with maximum and minimum. But there's my box plot. It's a box plot of candy bar fat. It gives some of that data that is useful when talking about distributions. Now, if we look at that, you can't tell a ton when describing it. But what can you tell? Let's look at some examples and see if you can guess. I have several of them. What can you tell about the shape? So box plot number 1, or letter A. Do you think it's symmetric, non-symmetric, normal, skewed, uniform, bimodal? Take your best guess, and I will show what it actually is. Well, this one's normal. I don't know if you guessed that, but it is normal. Not quite the best to tell. My guess for this next one would be uniform. Seems very uniform to me. However, it's bimodal. Would have guessed. Next one. So C and D, I actually would say you can tell. I think it's skewed. You can see most of the data is on the right side, and then there's that one off to the left, or the opposite for D. And that is the case. We got skewed left, and then we got skewed right. And the last one, take your best guess. It just so happens to be uniform. So I'll show you the matched up like histograms here. That first one, which we said was normal. B we said was bimodal. Kind of not the easiest to tell. C and D were those skewed ones. You can kind of tell that. And then back up to E on the right, that one was uniform. So sometimes your guess is as good as mine, but sometimes we can tell the shape. So box plots are great for certain things and not great for others. They do hide a lot of information. So you can't see if a distribution is unimodal, modal, or multimodal, or basically normal, or bimodal. So I guess multimodal, bimodal is part of that. You also cannot see clear gaps or clusters. We don't know, but you can see outliers. You can tell if something's really far away. So what is the point of them then? Well, they give a good summary. They're quickly, like if you have two of them, you can quickly compare different features, maximum, minimum, spread, and whatnot. They show specific measures. We're talking about like the median, the IQR, the range, as well as like the quartiles. So there are pros and cons to both, but what we can do if we're asked to do SOC-V for these, for shape, and summarize this as you want, you can do symmetry. You can tell if it's non-symmetric. You can clearly tell if it's skewed one way or the other. Everything else is going to be symmetric. You can't really see peaks or tails. So you might say something like it appears the box plot is maybe roughly symmetric or skewed. You can say symmetric. We don't know if it's normal or uniform, bimodal, whatever. But we do know if it's skewed. Well, you can also say it's difficult to know for sure what the shape is without a different graph. Outliers. You can't see clusters or gaps, but you should be able to see outliers. Measure of center. The median is right there, so you can do that for sure. And measure variability. You can do the range. You can even do the IQR. If either of them seem significant, it's worth noting. So you can do parts of this. You just can't do all of it. So I want to give you this. We did this data already. We looked at this data from a previous example, and if you make box plots for these and you want to compare them, I'm just going to make one note. Use the same number line. If you don't use the same number line, it's not going to be easily comparable. You want it to match up kind of like stem plots, back-to-back stem plots. So instead of having you do this, I'm going to show you what the comparison is. You can kind of see it at the top with Widget Wonders. The data is generally higher. So there might be questions. You might be like able to make statements based on the fact that over half of the data for Widget Wonders is higher than quartile 3 in Pieces Perfect. That's something that seems significant. The median is clearly higher. You could find the range. You could find the interquartile range and compare them. I don't think you can really tell the shape for either of them. They're not super clear. But you can also tell outliers, and there are outliers that are out here for Widget Wonders, and those both fit the definition of an outlier, that 1.5 IQR rule. So you can do a lot of SOC-V comparison. So I have a couple examples, whether we get a lot out of them or not. This one says a student placed 180 degrees of hot water in each of the 4 cups and measure the difference in temperature of the water after 30 minutes to see what was the most effective for maintaining temperature. She repeated the procedure 8 times, and she did it with each cup. Because some people want to know, what's the best mug? Well, which type of cup lost the most temperature in a single observation? You can tell that. That would be cup C. This is the highest amount. If you're looking at the change in temperature, there's one that lost, that looks like close to 30 degrees in the time. Nothing else got that far. So that would be your answer to question 8. On average, which type of cup retained the most temperature? It's hard to do averages, but if I look at this, this is a very small box plot compared to the rest, and they're all very close to the top. I should say bottom, the zeros. So I would argue that it's B. Now you could look at D and say it looks like half of the data, because that median splits it in half. Over half of the data is very good. It's very low. But then there is some more variability. Question C, which type of cup had the most variability in temperature changes? Well, you can kind of estimate that is from like, I don't know if that's 17 to 2, so that's a 15 spread there. And the IQR is fairly high too. If you look at this one, it might be like 25 and 9, so that's potentially a little bit higher. This one goes from like 1 to 18, that's potentially higher. So it's hard to tell exactly. They're all pretty close. But if I were to guess, I'd actually say A. I think A is the highest spread. Which type of cup would you recommend to keep coffee hot and more consistently? I would definitely go with B. There's not a lot of spread. They're all fairly low temperature change. So that's something we can do to compare box plots. Here's another one. If you're comparing some of the greatest hitters of all time, Babe Ruth, Lou Gehrig, Mickey Mantle, Robert Maris, I think it is. We have their home runs in different years, and you can see all of their years lined up. Maris has the highest, but he's also, it seems like it's almost like an outlier. Big spread, and a lot of the data is down here. Whereas Babe Ruth was one behind him, but looks like all of his years were higher than almost half of Maris's. So you can do a lot of comparing, and things like for Robert Maris, I'd say that was just skewed to the right. You know. So, like we said before, box plots, useful for getting some quick data, not always the most useful for comparing, but it is doable. All right, so make sure you know how to construct a box plot and how to find the different pieces that go along with it. We'll see you next time.